Oh, right. A direct variation is a relation in which one variable is a multiple of the other. So, for example, if I pay $10 a month for Netflix, 0 months, it's going to cost me $0. 1 month, it's going to cost me $10. So we would say cost is equal to $10 times the number of months. If we look at this on a graph, it's going to start from 0, 0. It's a direct variation. It's only one multiplied by the other.
So direct variations start at 0, 0?
Yes. Direct variations always start 0, 0. And I'm still bad at connect the dots. A partial variation is a relation in which one variable is a multiple of another plus a constant. So we've seen a few of those already. So, for example, a local gym membership might be $12 a month plus a $25 sign-up fee. So even if I go there for 0 months, I still have to start off by paying $25. So our equation would look something like this. 12 times the number of months plus my initial startup fee of $25. Alright, when we look at this on a graph, it doesn't start at 0, 0. There's a constant here. So, when we're looking at partial variations, there's always a constant. And here, our constant was $25.
You kind of spelled that wrong.
Constant? Okay. Constant. What? Constant. Alright. This is why I still need spell check. The y-intercept is the value of the dependent variable, so y, when the independent variable, x, is equal to 0. So, let's say I want to binge watch all of the episodes from last week tonight.
I do that every day.
If you've never heard of it, it's an excellent YouTube channel. But I've already watched the first 8 videos. I decide to watch 2 videos a day. If we notice, our independent variable here is equal to 0. And our dependent variable is equal to 8. This makes our y-intercept 8. It's a little bit easier to see on a graph, because if we take a look at this line right here, it's literally intercepting the y-axis at 8. That's why it's called the y-intercept. Ladies? So our y-intercept is right here, where the line intercepts the y-axis, and where x, our independent variable, is equal to 0. We can also substitute 0 in for x to find it. So if I were to substitute 0 in here, so y is equal to 2 multiplied by 0 plus 30. What would be our next line here? What's 2 times 0? Anybody?
0.
0. So y is equal to 30. So our y-intercept is 30. Something funny? Yeah.
Stop.
What's our y-intercept? Our y-intercept is our constant. So if you look in the equation, we have a constant of 30. Our y-intercept is 30. That's no coincidence. our constant is our y-intercept.
How do you know that's a constant? Because it doesn't change.
Because it doesn't change. Exactly. This one's one of the easier definitions. A linear relation is a relation in which the graph forms a straight line. I mean, if we look at the word, line is even right in the word linear relation. And everything we've done so far, this one, this one, this one, they're all straight lines. So all of these are linear relations. So a linear relation looks something like this. It's a straight line, or this, or even this. Any one of those. What matters is it's a straight line. So in the homework yesterday, you should have encountered at least one of the graphs that was not a straight line. It should have looked something, 2, 4, 16. Should have looked something like this. That's not a straight line. Ladies.
No, straight.
Something like this, not a straight line, and something like this. That's definitely not a straight line. Alright? So a linear relation is a relation in which it forms a straight line.